only one-way signals, right? So this is all going to come this way, right?
Mm-hmm.
Yes.
Yeah, what happened?
No, I just like stupid camera.
Oh, that's fine. Okay. So this is the supervisor control. So this is the single board, probably 64-bit computer, right? And these are going to be, well, this is not you. The MEs are going to do this, okay? So the mechanicals are doing this, okay? That's the mechanicals. They're doing that. So we haven't decided on this. We don't know any of these things here, right?
Right.
And there may be more here that we want, right? So
Yes.
this is, so the depth means it's going to be at least stereoscopic.
Right.
Right, so the depth sensor means it's going to be a stereoscopic camera. It's got to have like human eyes. It's got to have two eyes separated by some distance so it sees depth.
Mm-hmm.
Right?
Right.
They've already got one downstairs. Those
Right.
all those gaming, those
Yeah.
gaming computers have that stuff already. So now you already have the spatial room sensors already set up too, don't you?
Yeah, we have the spatial room sensors.
Uh-huh.
Yeah, but the robot also probably needs to know where its location is.
Okay,
Yeah, sure.
but we can do that. We can do that from. So you want some?
We have the
you want
position
some?
sensors.
Okay, so
IPS sensors, indoor positioning sensors.
Okay. So we
The
want
IPS. And we already
IPS
have
sensor?
sensors for that too.
Yeah.
right, but now we can do dead reckoning from the IMU,
Right.
or we can use some kind of radio telemetry. I mean, are we going to have a field that we can know positions in terms of
Oh, yeah.
signal strengths? Is that what
Yeah.
this IPS does?
No, this is
Tyson.
so the one that we have downstairs
Uh-huh.
has I think maybe 5 or 10 centimeters resolution.
And it's using like capacitance,
No, it uses
radar.
it
LiDAR?
uses, no. Okay, I didn't have a coffee yet, but
Yeah.
it uses ultra wideband.
Okay.
Yeah, ultra wideband RTLS system. Ultra wideband
Ultra wide
band. Yeah, RTLS system. It can-
RTLS stands for
Real time location service.
real-time location service. So this is using a radio signals from a transmitter somewhere.
Right, yeah. It
So you have
needs-
to have in four
we have
corners
to
of the
have
room.
beacons, yes.
There's
yes.
beacons.
Yeah,
Okay,
yeah,
so
there's
there are beacons. All
So,
right.
so we already set it up in our lab downstairs. So
All right.
this can actually sense in like 10 milliseconds.
Yes, sir.
Yeah.
And you saw that, right? I mean, it's
Yes.
probably like 10 centimeters resolution. So,
All right.
it's,
So that you might also want some collision detection. So you want to have local on this
Yeah.
perception module. You want to have, either LiDAR
yeah,
or sonar
yeah,
sensors.
right. Probably something compact.
Yeah. So these would be like the sensors on the back of your car now, right?
Yes, sir.
Backup sensors.
They can give you the 360-degree view.
Yeah.
There are some that will do 360. And again, this perception stuff, it has to be 360 degrees.
Yes.
So it may actually be radar too. LiDAR, radar, or sonar. I don't know which one would be the best one, okay?
Yes, sir.
So part of your, I guess, task is to write down all the requirements,
Yes,
right?
sir.
Take the design, Dr. Davis here, and then write down all the requirements.
Yes.
ECEE, MCHE. So that's how we'll segregate it out.
Yes, sir.
So our part we're gonna do the electrical stuff, and the mechan they do like the wheel coding and everything.
We're just doing all this. So the mechanicals are going to work on this part of it. Okay, so you will also have access. We can get you access to this position. These wheel encoders that can be coming back through here if that wants to be. If we want to put that part of the inertial measurement unit.
Yes.
Okay.
So,
All right.
Yep.
But we have this is not specified. We don't know what this is going to be. and we don't know what this communication module is going to be, and we don't know, well, we have this pretty much, right? We've got the IPS, we know we have that system downstairs, but not the onboard aspects of it, right?
Yeah, right.
So let me put a check minus on this. Okay, so you still have to do work there,
Yes,
right?
sir.
We don't know the cameras. We don't know which IMU we want to use. And then these spatial room sensors are basically the IPS, right? Is that right?
Yeah, so those are probably beacons, yeah.
So the spatial room sensors could also be, are we going to have cameras up top to see what we can do, the location of the machine with cameras, or no?
I mean, we can certainly do experiments. We have a overhead camera already in place.
All right, so let's,
We have multi-modal
this may
sensors.
be tied
Yeah.
to the IPS.
Yeah.
Okay, so that those two may be together. Okay,
Yes, sir.
these two right here. These may be part of the same thing. Okay,
Yes.
all right. So this is on board. All of it is on board. Okay, this is on board. And then this is on board. And then this is partial on board, right?
Yeah, right.
Partial on board, right? We've got we got these capabilities of the cameras. They do color, they do depth, and then they may be connected to that wireframe software that you have, right?
Right.
So that way the machine can tell where moving objects are and basically their location in space relative to them, even their swinging limbs. So that way we won't run into those too. So. And hopefully it won't steal our lunch in 10 years, right? Or 5 years or whatever, right?
Yeah.
When the machines take over the world, right?
We good. Don't worry.
We're rapidly making our own dystopian future.
Scary. Scary.
So we're going to handle that part, and then you guys got to work on this.
Yes, sir.
It's still really nebulous, okay?
Yes, sir.
I understand.
I mean, yeah, I think the goal is to kind of build a platform, right, that can sense n number of things.
Yes.
So we can use it for, industrial applications, safety. You can use it for sports, all kinds of stuff. So,
Yes, sir.
I mean, if you look at all the use cases, I think this platform should be able to satisfy all those use cases. I mean, we might do like very specific customization later on.
Yes, sir.
So,
Since I'm probably not going to get a secretary for, so I need a robot to go get my mail and get the mail from the
let's do it. Yeah.
from the down at the mail room. So no, I'm just kidding. So
We can do that. I mean,
Yeah.
I don't think it's a hard problem.
no, that's not a hard problem. Just need to be able to navigate St. Mary's, right?
Right.
Wait on the.
I
Oh
mean,
yeah,
they
we
make
also
a-
would want. We also want sound sensing, right?
Oh, yeah.
Sound. We want to be able to
Yeah, right. Microphone.
microphone so we can,
Copy.
so commands like if somebody says stop, it'll understand what stop is and things
Yes,
like
sir.
that. Okay, all right. So we want a microphone and a speaker. We want to be able to, we might be able to put a beeping sound out or whatever, And you could obviously go look at what other people have done, companies and things like that, and look at the sensors they have on, so some of those hospital robots that you see that are carrying pills around. A lot of those they're just guided. They follow a path on the floor that's been painted onto the floor and things like that. And there's also automated guided vehicles in industrial settings like the Amazon warehouses and stuff like that. And I don't know if those are fully autonomous or if they follow a path that's been laid out by either sensors or some kind of line following. You can do that with just sensors pointing at the ground and do line following. So, yeah, we had a group last year or the year before that did that for one of our local companies. Did line following. Anyway, okay.
Yes, sir.
It's look like the block diagram is there already.
Well, yeah, you can just kind of modify that to what get it into the form for your functional block diagrams that Dr. Darby was talking about.
Yes.
These are just idea blocks now that could be considered a functional block, but I don't know what your requirements are. But this is the basic idea. We need you guys to work on this one here, right?
Yes,
So
sir.
this is a high-level diagram, not
Yeah.
necessarily a functional diagram, but a
Right.
high-level diagram. And,
Yes, sir.
I mean, I think based on the inputs that you receive, you can probably develop the functional block.
So you guys are going to need to help us specify this based on what you need to communicate to these sensors. Okay.
Yes,
All right.
sir.
So now you may have in this set some Pi boards and everything that are running these things, and that's fine as long as we can communicate to them from our main thing. Because the AI or the machine learning. The machine learning / AI is going to be on this part of it right here.
Yes, sir.
Okay. All right. Okay.
I think the variables here are cost, number one. I guess we'll have to derive some specific performance measures related to the perception module, which is how, like when you're talking about depth sensing, right? How far can it see?
Yes.
What are the errors? And how are you gonna? Yeah, so I think we have to kind of write down all the performance metrics, the cost and
Yes, sir.
accuracy and things like that. I mean, if you want specific tasks, I can give you
Yes, sir.
perception tasks that it needs to sense. I can give you those tasks
Yes,
Yes.
sir.
very clearly, very, very clearly.
Yes, sir.
So you can, and I'll also give you the software that'll do the detection, right?
Yes, sir.
The activity detection or whatever. So you can actually measure the performance, right, accuracy of detecting those specific tasks. So
And we will have already on board 24 volt supply. All right, so we will have some kind of a supply bus, okay, that you can get your power off of, okay?
Yes, sir.
All right. But you may need DC to DC converters or whatever to get you down to the voltage levels that you need there. Okay.
Yes, sir.
Okay.
So again, these are all your design choices, but it might be possible that you just have some kind of voltage regulator to supply power to this computer, and then this computer feeds power to all of these, or maybe you have separate power to the sensing modules and then separate power to these. I think those are
Right.
all your
Yes,
So
sir.
you can
Design
decide that. So
choice,
like if you
design
guys were to
material.
go with USB-C or something like that, you can more than likely power all of those guys through the USB-C bus. Maybe even USB 3, I guess it has power on that bus too, doesn't it?
Yeah.
You can use here, but we'll figure that out. Okay. So this should have all the different USB buses, all the different communication protocols on it, I would imagine. So,
Yes, sir.
Yeah.
Sure.
USB, not A. USB-C.
Can I ask some question?
yes.
Don't know.
Absolutely.
Yes. So you think how far this project will go? Like the goal we want to do in the end of this robot, will we play the tennis?
No, he won't be playing 10. Well, Maybe by the, are y'all a 2-semester thing?
Yes, design 1 and design 2. Yes.
Maybe maybe next December it might be.
Yeah. I mean, I don't know about tennis, but racquetball.
Yeah,
Well, it may be able.
racquetball.
Let's say by next December, we should have it moving, and in the field freely, right?
Yes, sir.
So yeah.
So at the beginning, when we talking about this voice system, this is a video device, and at first we thought this is what you want we do, like we try to avoid the
Obstacle avoidance.
Yeah.
Yeah, that's what these sensors here do.
yes,
These LiDAR things like that. You just need to specify that. Now that is probably capacitive.
yes, I think
Okay.
so.
Yeah, that's capacitive. So this could be, you could also put capacitive in here as well, all right? So that's a possibility. Okay, capacitive is a possibility.
Yes.
Okay, but that's real close. Notice that that's real close.
Yes.
So the LiDAR and the sonar will work at feet,
Yes.
so that will give our AI time to figure out what to do with the moving target that's going to be in that part of it, plus all the other sensor information, okay? So there's going to have to be some sensor fusion going on in here too. That's got to happen, that logic,
Yeah. So
that has to be done probably right here,
Yes,
okay?
it's some software.
Yeah, that will be a software issue. And you guys aren't responsible for the software. Okay?
Yes. So basically the sensor we have most of this, right?
I'm sorry.
The sensor on this table.
Mm-hmm.
So we have almost of that in this in the room we made on
No,
Friday.
part of the IPS is there,
Yes, sir.
right?
Yeah.
But none of the other stuff. So y'all have to specify all that.
Yes. And so how much y'all can fund? I mean the finance.
I'll buy all of this for you. I mean, there's a limited budget. It's not
Yes.
infinite, but
Yeah.
yeah. I mean, yeah, we'll buy this all of the sensors.
So you guys have gotta go find what modules you want, and then get the cost for it, and then you gotta build a cost
And make
sheet.
sure that competitive to
Yes,
everything.
yeah. You want to make sure you get a good sensor for a reasonable price.
Yes, sir.
Right. Okay.
Like so the goal is like low cost but like working good, something like that.
If you can.
So we have to build your design against certain performance metrics and cost.
Yes.
Okay.
So do you think this is the plan we made from this robot in the future?
I need to get my glasses.
Sorry about my
Well, that's
handwriting.
okay. I just gotta get my glasses.
Yes.
What is this again? This is a project plan. What is this?
Yeah, like kinda what we thinking about for this robot in the future. Like what? So because I want to plan out, so I will know what kind of the computer, the AI, what should we do, so we don't need to upgrade for next one.
Yeah, yeah.
And
I mean, there are some good.
for,
There are some powerful microcontrollers
Yes.
now.
for now,
They have onboard GPUs and stuff. I mean,
yes. And I see right now the Pi Zero, it kind of runs slower than the new version. So
So those Pi boards over here,
yeah,
don't
those
worry
are
about
here.
those.
Yeah.
Those- that's
See, look. I think the computer-wise, I mean, there are several options.
Yes,
not
sir.
just one. For example, Qualcomm is making some new boards
Yes.
that they're using in industrial service robots and stuff like that. I mean, there are platforms that you can just buy,
Yeah.
and connect all of these together.
yes,
So yeah, I wouldn't be too worried about the computer. I mean, yeah, there are options. Yeah, I'd like you to go do research and see
Yes.
what's best. And I think the most power-consuming component is really the camera, the perception module, in my opinion.
yes, sir.
I think number one. Number two,
The motors are gonna
oh yeah,
pull the most
that's
power.
the power, but I'm talking about the computational.
Oh,
side, the
computational power.
computational power, right?
Right.
So not the actual power.
Right.
So I think what we're going to do is initially we're going to do a lot of data collection.
Yes,
right?
sir.
I think we have our PhD student who's working on reinforcement learning approaches for path planning and stuff like that. So we'll be collecting a lot of data, but the training will not happen here. It'll happen in a more powerful computer outside of this.
Yes, sir.
Okay. So I would believe that the cameras, the perception module is the one that'll take the most computation.
Yeah. So all those sensor and camera and everything. So we will put. So you think we should put in the one board? I mean, in one. It's simple. Like I just put all sensor on data to one CPU, then I send those information to another CPU to their process, so they can communicate each other and they know.
Communicate with what? You mean the robot trying to communicate with some other external entities, or what you mean?
Yeah, similar like that. Like I have one board for all sensor like camera and everything in that iChip, in IEEE.
Mm-hmm.
Then I will put the information and I will make the robot will know where they are and what the environment around them.
So you're asking if all of this computation is done on one board, or
Probably two. Yeah, two.
I think you're asking, right? If
Yes.
all of this happens in one board or two separate boards.
Yes.
I mean, I'd like to hear from you. I mean, what's the best way to do it? Is it better to have one small sensing module for some of these, and then have or combine all the processing in one board?
Yes, because I didn't know about the small computer. Like I'm not really going deep on that thing, so I don't know how the powerful it can go.
I'm sorry. How to do what?
How strong it can process. Like it go fast. If I put a lot of data in there, it's still able to process this data, then transfer information to do what they want to do.
Yeah, I think it is a design choice. I mean, I can see that you can have good communications between all of these.
Yes.
Without very low latency, and I can see all of this happening here.
Yes, sir.
But it may be a multi-core board that
Yeah.
you could have. You could do
Multiple, yeah.
do the processing in parallel for that. It may not have to be separate boards. It could be a multi CPU design. Like a 4-core machine or something like that.
Yes, sir.
Some of this can be done on GPUs that may be on the board on the computer too.
Yeah,
right?
yeah, it
So-
has to have a GPU, otherwise the perception module will not work. I mean, the GPU is mandatory, no doubt.
I understand.
Yeah, and it's multi-core too. I mean, even the phones have multi-cores now. So
Yeah.
Yes. And the power supply. So you want power supply here
No,
for everything.
We have a 24 volt power supply. Okay, so you assume that you have access to 24 volts, and then you need to break out whatever voltage regulators you need for your particular bus. So that
Yes.
24 volt bus will drop down to a 12 volt bus or whatever you need for all your modules. Okay,
Yes, sir.
all right.
Because I see your motor is very big, so I think it takes a lot of energy, go very fast.
That's right. It's
Yes.
going to suck it down
So,
really
I
quick
mean, do you think I think it might be better to have two separate batteries,
if you want.
right? Because that way your computer is not affected by
All right.
the
So,
motors.
but that's okay. But when we're on the wall circuit,
Yes, I'm
you can
doing.
assume that you have that available.
course,
Okay,
yes.
but then
Yes.
when it's autonomous or independent, we'll have a power supply, a voltage, a battery for the computational side, and a battery for the wheel side.
Yes,
okay?
sir.
And
That's
that way
really
there's not
good.
any. But you can use
the power
I mean,
bank.
you can use filters and things like that, but again, I'll let you guys decide what we need, right? If we need two separate supplies.
Yes,
Now,
sir.
there's a limited platform space and all that stuff too, so you have physical dimensions that you have to work with also.
Yes, sir.
Okay?
I see.
All right.
And like next year, you will make the team to build an arm for this robot.
The what?
The amplifier for this robot.
No, the arm,
The amp.
the
The
hand.
arm,
The
yeah.
arm.
Yeah,
Sorry.
I think
Yeah, I guess. Probably we'll have a mechanical team work on that next year.
Next
yeah.
year.
Yeah.
Yes. So
We gotta get the platform running first, the
Yeah.
bot, the base.
Yes.
okay?
because I want to know like where I should put the camera. I mean the sensor and everything, so I don't get stuck with the
Well, you'll
arm.
be, yeah, good question. So
I-
you'll have, you could imagine that you come up, some amount. I don't know what that number is
So-
gonna be.
I mean, Alan, don't you think if we just, put the camera at maybe a certain height, it should have visibility even if it has an arm, isn't it?
Well, I agree, but is the arm gonna hit it? That's the question. All right, so, it's not, because it's an Omnibot, we can actually, well, the problem is actually hitting the ball. We could make the platform do all the ball hitting, okay? And
Yes,
so
sir.
the arm is just a fixed paddle, we haven't decided on that at all, so.
Right.
Yeah.
It's a good question.
But you could, your sensor, your perceptions, your camera and stuff like that will be mounted on something,
Yes,
right?
sir.
And then we'll be able to, although when we train it, we're gonna have to train it from the same position, right?
Right.
Let's see if we can give you a number on that just for now.
Yes.
Don't worry so much about that height. Just
Yes.
do the electrical side of it, and then we'll figure out the geometry a little bit further down the line. Okay?
Yes.
Yes, sir.
All right?
Because that's still be fine. Because when we do the sensor, wherever we put that, it still will know where they are.
Right. But we'll have to settle on that a
And-
little bit further down the line.
Yes, sir.
It's a good question. So, in order for you to get the 360-degree view,
Yes, sir.
you have the spatial room sensing. You
Yes.
have one source.
Yes.
Okay. So now the question is, would you put cameras in the center? Would you have one or two cameras in the center? Or would you have cameras around?
Yes.
What would be best? Maybe.
Yes.
Yeah, the idea of Papa told me like you're gonna boot around, so the sensor sometimes like it's leaning 45 degrees. So so for example, if the robot is like moving, and if it see like something like the holes in on the street, so it's like it avoid that and
Yeah,
so-
but I think we're planning on just working on a horizontal surface for now,
Yes, sir.
right?
Yes.
But you got to remember that the robot can move
Yes.
in any orientation, in any direction. Okay, so if this is the front of the robot, it
Yes.
can move this way, but it can also move like this. Okay, it
Yeah.
doesn't matter the orientation; it can move in any direction. All right?
Yes, sir.
Yes.
So your cameras have got to have some kind of a 360-degree view. Okay,
Yes.
Yes.
so.
Absolutely.
I don't know, do they have a fisheye,
Yeah.
two stereoscopic type cameras where you could mount, the fisheyes are looking, the 360 field of view? There might be
There
something-
are some, but they're very, very expensive.
Okay. So you guys may have to decide on having, cameras on each of the square sides of the robot, and then our
Integrate.
our logic, our sensor fusion is going to have to figure out
Combine
which data makes sense. Okay.
Yes, sir.
Yes, sir.
And so that will be a software
Yeah.
coding,
So again,
coding
yeah,
issue.
fusion.
Yeah. The fusion logic. So
Fusion modules.
physically mounting, but putting those. So, we talked at one point when you all weren't in here. We talked about putting the cameras on a rotating platform, but I think you just mount 4 cameras.
Yes.
It's cheap. I mean, the
Yeah.
camera, especially the RGB sensors, are cheap.
Yeah.
And you can probably get the stereo. I mean, there are cheap stereoscopic vision cameras where you have like 2 cameras.
Yes.
So one possible option is just mount one of those on each side. I mean,
Okay.
they're expensive ones.
Yes.
I mean, the one that we have down is $450. It's a very expensive one, but it's the best in the market. And there are some in the range of 100 to 150, and there are also some in the range of $50, $60
Yes, sir.
that actually work with the Arduinos and Raspberry Pis.
Yes.
So something to investigate.
Yes, sir.
It's still investigate.
Yeah. I think, like as Dr. Darby suggested, you should kind of start with the big functional block diagram,
Yes.
right? That he
Some
talked
kind of
about. He calls it what, level 0 diagram? Is that right?
Yes.
Yeah,
Level
level
zero.
started. Yeah, level
Similar
0.
like your, but different a little bit like what we do with a sensor and a communication and
Yeah.
how it process. Like if we see the stuff in the front of like the people with the ball with the object, like we want to touch the ball, but the people in front of the ball. So
Right.
we will avoid it or we will go around to touch it or some kind of that.
Yeah. Yeah. So I think, I mean, since now you have some big picture,
Yes.
maybe you can kind of try to write down the functions / requirements
Yes, sir.
on what this will do, what the, I guess, I mean, if you have more questions about very, very specific functions, in terms of how long, how deep,
I
how
think-
fast.
I think
Right.
this one we have a lot of information. Like right now, I have to know. I will go to your office and ask what's the sensor, what we have in there, what do we have in here. So we don't need
I
to
think
buy.
it will be a good idea for you to learn
Yes.
what we already have,
Yes.
so you know what the capability is to some extent.
Yes.
Right.
And like I don't need to buy a new one, then learn on that thing. Like what,
Yeah.
Because I need to learn and I need to test that to know
Sure.
the.
Yeah.
the-
Yeah, we have actually we have Sunjin, who's our mechanical engineering MS student working on that. So
Yes.
we can give you a demo and stuff. Yeah.
So do you want we do the coding for those input go to one row? Like do you want we do the coding or we just do the research and find the information for those camera and sensor?
I mean, again, when you talk about coding, there is so much that needs to be done here,
Yes.
right? So obviously, you want to define your scope really well on exactly what you
So
have to do.
so just only
One
what
thing
we
that
do.
is certain is that you'll have to figure out all this
Yes.
electronics,
Yes.
right? The computational hardware, and all of that. So you have to figure that out.
Yes,
That's
sir.
you're definitely doing that.
Yes.
Okay. Second, I mean, we can give you some software that will actually try to integrate. I'll have to do this anyway. So we will work on some of the software stuff.
Yes, sir.
I think the scope should probably, there'll be coding tying the data from the IMU, all that kind of stuff into the communication model. So there's going to be a certain amount of coding depending on what interface you use for all those modules. Okay,
Yes.
so you're going to have coding that gets you down. So whatever's in that communication module, you'll be writing that underlying code that talks to all those sensors. And then it may be that communication to the computer is through the USB-C bus or whatever. We want to have access to that.
Yes.
Not sure what that is. Okay.
So, data collection module. Okay,
Okay.
that means you should be able to give us an interface to access data from any sensor
Right.
Yes.
Right.
on this computer.
Okay.
From that
definitely.
computer. From that computer.
Right.
But the communication module may be where you actually do it.
Right.
Yes, sir.
Right. Okay.
This is definitely, you're definitely doing this.
Yes, sir.
And that'll take some time,
Yeah, that will take a lot of time because if you ask me to do the coding for camera to understand the distance or
You don't
something,
have-
yeah, we cannot do that.
No, I mean, so we have some
Yes, sir.
software.
That's they're working on that downstairs already.
Yes,
Okay,
sir.
So I mean that's going to be part of the machine learning AI that's going on the big computer.
Yes,
right?
sir.
So we just need you guys to give us the sensor data.
Yes, sir.
okay? All right.
Yeah, I think we're able to do that.
All right.
Absolutely. Sensor.
Sensor module.
Sensor
Module, sensing module.
Sensing. Oh yes.
The design of that.
So,
And we call it communication module, but it could be just change it right there to sensing module.
maybe I'll just say sensing and communication. Okay. Yeah, maybe some of the fusion,
Yes.
maybe you can do some fusion, we don't know yet, but some of the fusion maybe, is beyond the scope of your project.
Yes,
Dr.
yes.
Darby will help you figure out what y'all are actually going to get done in the amount of time, okay?
Yes, sir.
So if you give him a picture of what we're thinking about, he'll be able to help you narrow down what you can actually do in a 2-semester course.
Yes,
okay?
sir.
Yes.
All right.
Yeah.
You know, we want you to have a terminus, but it still may be quite a nebulous terminus. Okay, you know what I'm saying? So I'm hoping we hope we have a functioning system when you're done. I mean, but you may not have all the software or the exact software. I mean, because we may need to be able to change your software to interface with it, whatever what we decide, right?
Yes.
So, you know.
Do you learn, did you take any classes in like embedded systems, microcontrollers?
Yeah.
You took those classes?
We do microcontroller like
You did
with
microcontrollers?
with-
What language did you work with?
Arduino, C++,
C++ is
Yes.
what you did? Okay,
some kind like that.
I see. I mean, see, the operating systems that actually run on these, you have Linux-based systems.
I think if I
You can
able to do
do
the Python.
Python, yeah, you can
Yeah.
do Python, you can do C, C++, all of that.
I think Python is like it's more easier.
Because Python it have a symbol syntax, so
See,
we able to do
symbol like
Look, it's,
command.
it's an
See.
interpreted language,
Look.
though,
Yes, sir.
right? So it's not it may not be fast enough for what we need. So
Oh,
Look.
I got it.
I mean, look, there's so much software stuff that is out there,
Yes,
Yes, sir.
and there are actually modules that I can go buy
yes,
that has probably 80% of these sensors, and they'll also give you interfaces to basically go and get the software we need. You know what I'm saying?
Well, that may be what you'd specify as well. Okay, the cost. So when you add up all the cost and it comes down and it's less than
Yeah.
one of these unified modules,
I
then
mean,
we just get the unified module.
Yeah, there's stuff out there. It's just,
Yeah.
I mean, it'll give you all of this. I mean, I just need to just hook a bunch of cameras and get all of this stuff.
I understand.
So I just want you to know that it's not hard. There's a lot of stuff out there.
Yeah.
Just go and look and you do research
time.
and you'll understand. I mean, this is, yeah. I mean, they give you access to all of this. It's just function calls and stuff. I mean, it's going to take some time to set it up, but
Yes.
okay.
So yes, we will ask Dr. Darby like what he want we to do.
Yeah,
Like,
and
then we
I
offer
would
him-
encourage you to. I mean, if you want, I can send you some references and links, and
Yes, please.
just to let you know, like,
Yes, sir.
it's not
Yeah.
that hard.
Yeah, please send everything if you feel like it's happened.
I mean, yeah, you have to ask questions, right?
Yes,
yes,
sir.
yes, absolutely, yes.
The questions will arise naturally as you're digging through, figuring all this stuff out. You say, okay, now, how do we do this? And then you ask us some questions, and we may be able to give you a pointer, and then you'll decide on what it is.
Yes,
Okay?
sir.
All right. It's not a textbook problem, okay? It's
No,
very,
it's not.
It's very open ended.
It's like the real world right now.
The real world, right?
Okay.
Yeah.
Yes, sir.
Any other questions?
I think it's good for now because I have class at 9:30. So
All right.
I mean, are you familiar with the networking protocols and stuff?
not really.
I mean,
but
like
we
for
understand the
example, you
basics.
know how to connect to an IP address, a port.
Yes.
You know all those concepts, right?
Yes.
Okay.
Like we understand if we do if I do the Arduino, and we supply a lot of Arduino, and supply to a lot of sensor or even the LED. It will draw a lot of ampere or voltage, so it will not enough power to supply the sensor to work correctly.
Yeah, you gotta understand that you're gonna have a power bus
Yes.
and a sensor bus.
Yes.
Okay, so the power bus will power the sensors, and then the data is gonna come through that sensor bus. Okay, and everything's gonna be at different current and voltage levels and all that kind of stuff. So you're not gonna power things through your Arduino or your Pi board or whatever you decide to
Yes,
use.
sir.
You'll have a separate bus for that.
Yes,
Okay.
that's what
So-
we try to do.
Yeah, we're talking about milliamps on the signal side versus that camera, probably an amp and a half, 2 amps, something like that. I don't know what it actually takes. Okay?
Yes, sir.
So, all right. And those IMUs are integrated now on, like you said, some single board computers have them on there. So it may be that it'll be part of the board that we use, but you got to just figure that out. Okay. And they
Yes.
also obviously sell IMUs on a chip, because they're everywhere. They're on the phones and everything, right?
Yes, sir.
So yeah. Okay.
There's a lot of open source stuff out there. I mean, especially for robots.
Yes.
I mean, I can send you some sample designs. I mean, I can share some open source projects that are out there.
Yes, sir. That will be
The
great.
most recent projects and stuff. So
Like the Mobile
I think that'll give you some confidence. You know what I'm saying?
So you guys go home and hack out what you think this big functional block diagram, this function zero, whatever Dr. Darby called it.
Yeah, we're gonna
And
meet
then
Dr. Darby.
send us a PDF of it or whatever, and we'll see if it makes sense. Okay.
Yes, sir.
All right.
I really appreciate your
No, I
connection.
mean,